So my name is Kruemcke, and I am the product manager for SUSE for HPC, for ARM, and for Power. I'm going to be talking about two of those today. Be talking about what we've been doing around HPC, and just as kind of an intro, a lot of people say, SUSE, what do they have to do with HPC? Do they do anything in HPC? Well, actually we do quite a bit. So we're actually the foundation for Cray Linux environment. So if you run CLE, you're actually running on a variant of SUSE. We have an agreement with them for that. But we also have a pretty big standing overall in the top 500. We think we're about 50% of the top 100 for commercial Linux vendors. So we got a pretty good footprint there, and we've been doing a lot of things around HPC over the last couple of years. So just kind of in the beginning, SUSE is an open source company. So everything that we do is rooted in open source. So we provide, all of our products come through open source, and our Linux distro actually works only with open source stuff. So stuff that comes through the upstream kernel is what we put into our products. We don't do side branches, things like that. That gives us kind of the foundation for doing a lot of interesting things with new technology, but it also helps to build our reliability and a lot of other capabilities. But fundamentally, open source. Now, there's a lot of different projects in the open source community. I'm not going to go through all of these here, but you see some of the major ones there, like Kubernetes, like NVIDIA, some of the things we're doing there and around ARM. So open source is kind of key to us, but there are a lot of different areas, a lot of different projects that we actually provide the underpinnings for us. For example, if you look at our SUSE Enterprise Storage, that's based on Ceph, the open source project there. But we actually went out and brought in something called OpenACC to give a really nice user interface. But everything we do is open source. Now, a couple of the companies are coming to the installations. LRZ is one of our big customers. The Supercomputing 6,500 nodes. It's running on a Lenovo platform on x86. That is a SUSE environment. It's running entirely SUSE HPC, along with our Slurm distribution. So one of the things you'll learn about it is not only do we provide an operating system for HPC, but we also provide utilities and libraries kind of augment what's out there and to make it available. Slurm is one of the things, as you'll see in a moment. Another good customer of ours, Barcelona Supercomputer Center. I want to get out there and see that sometime. It's supposed to be the most beautiful high-performance computer in the world. Haven't been able to see it yet, but that's yet another SUSE installation. I'm not going to give you any more of those, but I just wanted to let you understand that we've been in the HPC business for a long time. We have a lot of customers out there. What's changing is that we've kind of put an extra focus on it. You'll see some of those things. So if I look at overall what we bring to the table around HPC, kind of think of this as a foundation going up. So obviously operating systems where we're going to talk a bit about here today, along with the things that we provide as part of that. So I mentioned Slurm, but you see Open Blast, HDF5, you name it. We have about 30 plus packages that we deliver and actually support as part of our distribution. So it's not just that we make them available, we actually support them. HPC in the cloud, I'll talk more about that in a moment, but that's an increasingly large space, both for us and just for HPC in general. If you went to the Hyperion discussion yesterday morning at 7 a.m., they said HPC in the cloud has finally hit the inflection point. About 33% of the people they surveyed said they were doing some amount of HPC in the public cloud. An even larger proportion in hybrid clouds and in private clouds. So definitely this is an area where we've been investing in. Now ARM64 has been a big focus for us for quite a while. We saw that as a great new emerging platform. The thing that we really value about ARM in particular is the ability to have diversity of choice. When your only two vendors really are AMD and Intel, there's not a lot of choices there around HPC. So the ARM vendors are really building it out. In fact, we have a demo here with the Marvell ThunderX 2 running in a system with NVIDIA GPUs on it. We also have the Ampere ARM workstation. So we've actually got a couple of pieces of hardware in here. But this is an area where we see that the future is going to be very, very bright. I'll talk more about that in a moment. Software-defined storage, I mentioned already, we do Ceph. And I'll talk a bit more about this. We've used Ceph primarily as an offload or an archive mechanism for HPC environments, but what you'll see later on is that we've actually been improving the overall performance, and now it's actually starting to look like Ceph is actually a reasonable choice for some of the smaller HPC implementations. We're starting to get enough performance in there as the Ceph community has improved, and as SUSE has worked on it, we've been building that up. Obviously, accelerators is the big thing, has been the big thing for a number of years now. So we are members of the OpenACC consortia, and we've been working very carefully and very closely with NVIDIA specifically because they are the big dogs in the hunt. Lots of other accelerator technologies out there. Very briefly, Kubernetes, we do have an offering around Kubernetes called Container as a Service Platform. I'll mention that a bit more. That's an area that continues to expand, particularly as you look at HPC, and particularly around areas with either Docker-style containers or, more importantly, Singularity. Singularity is absolutely one of the big places, and that is delivered for us through what we call Package Hub. Package Hub is the way that we can deliver software that is community supported, but it's been curated by SUSE, so we don't just we don't just package it up and throw it out there. We actually do reviews on it. And if you talk to the Scilabs guys, when we took their first release of Singularity 3.0, we dug into it in quite a bit of detail, and we found some challenges, some issues that Scilabs needed to fix. So the stuff that's out here is curated by us. It's just not supported directly by us, or at least not at this point. But it's very easy to use. All right, so let's talk about our enterprise high-performance computing. So this is our operating system. We do have specific products specifically for HPC, and we started that about 2 years ago. Over time, you'll see the general purpose operating system get kind of further away from the HPC because there are things that we can do in our distribution to make it easier. I mentioned the software it's included. I'll talk more about that. One of the areas that we are different than the other guys around here is how we handle kernel upgrades. So some distros, they get on a kernel at the beginning of the version and they stay on it throughout the entire release and continue to do backports from upstream. SUSE has a different approach, or a slightly different approach, in that we actually adopt a new kernel every other release. And so, for example, we started out, my first release that I supported ARM on was the 4.4 kernel. Within 2 years later, we moved to the 4.12 kernel. Our next major kernel that we're going to be going to next year will be a 5.3 kernel. And you might say, well, what does that matter? Well, what it allows us to do is to capitalize on all the upstream work that's been done on the kernels since we first released our product. And so that's different than what the other guys do. They like to do more and more backports, and that limits things. That's why you see, full ARM support, for example, not show up really in Red Hat until they had the alt release. And now in 8.1, they finally converged those. So that's one of the areas. It's kind of plumbing, but it allows us to deliver a better product, better capabilities for our customers. I will point out that for our HPC, we are offering two platforms, the x86-64 and the ARM platform. So those are the two that we have out there. Even though we don't have too much ARM business yet, it is building. All right, I mentioned that we have a number of tools put together with our offering. This is a list of a few of them here. The difference here is that they're all supported by SUSE. So things like Slurm, we work very closely with the Slurm community, with SCEDMD and the other guys out there, to make sure that we're keeping up to date on that. And the same thing for some of these other libraries. Just to give you an example, and this is an eye chart here, we first started out with Slurm at 1702.11, then we moved to 1711.5, and now we're working on 1808.05, and it might rev one more behind that because I think there's another fix that has come out there. So these are all things that we provide. They're installable directly from our SUSE media, and we're providing these capabilities to our customers and continuing to add things onto that. So if you look at some of these here, like GSL, for example, or IMD, we didn't have those at the beginning. We picked up, but we're also updating the packages as we go along. So this is a big part of why we've invested into this. And one of the things that we're looking at is, where do we need to do additional packages? Are some things here maybe we don't need to do, but can we do them differently, like provide SPAC or recipes or things like that. But all of these things that we ship with our HPC module are fully supported by SUSE. Now, I mentioned HPC in the cloud before. We are working with both Azure and AWS. In the case of AWS, we already have images out there not only for their x86, but also for their A1, their ARM cores. If you saw the news just recently, Microsoft Azure just added internally support for the ARM ThunderX2 processor. So ARM is definitely coming to the public clouds. We're there for them, but the vast majority of this business is x86, and we're fine with that. Like I said, Hyperion said 30% of people already are using some sort of HPC in the cloud, so it's definitely where we're going. Now, I want to talk just a little bit about the Catalyst UK project. You might have seen some of the press around this or some of the news. This is a project that we're doing in combination with HPE, ARM, Marvell, Mellanox, and others. And basically what we did is we set up 3 HPC clusters in Bristol, Leicester, and Edinburgh. And so each of those clusters has 64 ThunderX2 nodes out there. And we've been working on this now for about a year, a little over a year. Like last year is when they were prepping the hardware to ship during Supercomputing last year. They've now been running a year. They are doing science with it. But not only are we kind of learning how, what changes need to be made, like for example, Slurm was pretty easy to get over there. We have an experimental Lustre server that we provided for ARM because EPCC Edinburgh, they really wanted to have Lustre there, so we have that up and running now. All of the accounts started out initially with PBS. One of them, EPCC, is now using our Slurm in addition to this. And then we also have one site that's using BGFS. So this is really, both an opportunity for us to mature up the HPC kind of infrastructure for ARM, and it gives us a lot of, the opportunity to have a lot of experiences here. So this has been a very powerful and capable project. And what's really cool is we're starting to see science out of it. You should see some more papers at ISC. They've got some really interesting stuff that they've done around genomics. In particular, I think one of the projects that's been mentioned is actually looking for a source for things like Alzheimer's and some other diseases. So, we're doing real science. It's out there. And in fact, if you're interested in experimenting with ARM and HPC, if you contact these folks, they'll be able to, in many cases, provide you with the opportunity to try out the code live. Okay, IO 500. So there's more to HPC than just compute, right? There is IO, there's data. And so this is an area where, I mentioned that we have the SUSE Enterprise storage based on Ceph. We've been pushing the performance limits of this. So there's a benchmark called the IO 500. We got published on this last year with number 26. This is a pure Ceph environment. Right now, we've only done x86. We went from 26th to 17th in this period of 6 months here. These are all x86 with SSD type drives. But like I said, we're continuing to kind of push the performance levels that we can get out of Ceph. The goal is that in a couple of years maybe we'll have a performance level that we don't necessarily need things like Lustre. That will be particularly smaller installations will be able to get by with using just Ceph. But for the environments that they're not going to fit for this, that it's not performant enough, we actually have customers today that are using our SUSE Enterprise storage as the offload for their HPC storage. So the idea is that you have your Lustre-based or BGFS-based storage. It's got your really high performance, but as the workloads run and the data is no longer needed to be on the fastest storage, you can migrate it or have it automatically migrated to the Ceph environment using iRODs or other capabilities. And the idea is it comes back automatically. So it's a way for you to, as storage keeps growing up, you can't put all that in Lustre. You got to have a way to manage it. What's nice is with, in particular with iRODs and DMF that we get from HPE, you can actually do that migration and recovery automatically. All right, I mentioned OpenACC earlier, and you guys have heard accelerators all over the place, and if you got got some of the keynotes from NVIDIA yesterday. I hope you noticed there were lots of lizards on there for a change. So that's some things that we've done over the past year, really improved it. OpenACC is an approach to come up with a common programming environment so that each person, everybody didn't have to program to each individual accelerator. So we're proud members of that, and that's something that we expect to continue to grow there. Just as a blatant demo here, we have a demo running over on the pedestal over there where we have a ThunderX2 Marvell system. Not exactly the quietest machine in the world, but we actually have an early version of the CUDA running on top of that, and we're running TensorFlow for image recognition. So that's something that our colleagues, some of my colleagues pulled together in the last couple of weeks. So if you think about it, NVIDIA announced that they were going to be supporting ARM at ISC, and we already got some prototype code out there. So it's definitely going to continue to expand. All right, I mentioned Package Hub earlier. This is where we curate open source packages for our customers. The basic idea is that customers will go out and say, hey, I want to use this package, but it's not widely used enough, or maybe it's got maturity issues. And so we put it into Package Hub so that our customers can install it with the same commands they would install any other SUSE package. They are community supported, but as I said before, we heavily curate these things. Now, the important ones there around HPC, Singularity obviously is one there. We currently have Singularity 3.4 in there. They just released 3.5 this week, but I think there's a 3.5.1 already coming. So they found a few glitches. So we'll keep Singularity there for a while longer as it matures, and then our path is to eventually start supporting it as part of our overall offerings. But what's cool about Package Hub is it gives us, as I said, a way for our customers to use open source packages that aren't part of our distro and aren't part of any distro probably, very easily to access those. Now we do also have a Kubernetes offering. It's called SUSE CaaS, Container as a Service Platform. So that's our Kubernetes platform running, allows our customers to run their OCI style containers there. So this product has been out in the market now for several years. I think we're on their 4th release now. We do try to keep Kubernetes up to date. I believe our target is 90 days from release, so we're really keeping this up to date because Kubernetes is moving very fast. As containers have become increasingly more important in HPC, it's important to have this blended in as part of our overall solution. So you heard quite a bit of stuff here in a very quick amount of time. Yeah, not too bad. We do have a SUSE Linux for HPC, but that's really just the starting spot, right? Having an OS, that's just the beginning point here. Key thing is providing these other HPC packages along with it is fully supported, and then the things around it, like our Ceph-based SUSE Enterprise Storage or our CaaS platform. We also have SUSE management platforms, but the bottom line is everything that we do is upstream, everything is open source. So, if you decide you don't like us and you want to go to somebody else, we're not locking you in. But we've got a pretty good business in HPC. My business grew last year by about 26% in a single year, so that's not bad. We're growing faster than the market. We're looking to continue to grow the market. All right, Russ. That's it for me.
Let's give it up for Jay.
Thank you.
All right, Jay, good job.